Yes, I found it. All right, here we go. All right, done. I guess I'm going to share my screen. Okay. All right, let's do like this. I'll be right with you, gentlemen. I'm still just kind of logging into everything. It's fantastic for the join. That's correct. Don't connect the audio. Let's use these on this. Stay as a participant. All right, thank you. Thank you. All right. All right. So welcome, gentlemen. Let me see. So this week, I hope everyone is doing well. Hope you had a great weekend. We are in the home stretch, right? We don't have that much left. This week, we're going to focus on exam 3. Let me pull up a calendar real quick. So right here. Okay. Hey. So again, this week we're going to be working on exam 3. So we'll do a study session today. On Wednesday, you can anticipate an attendance quiz. That's just, if you guys, you can ask questions from your exam. So, this whole week is devoted to the exam. If you're Gucci, then, just kind of take it easy. I'll stay. My intent is to be on the call on Wednesday. Again, I don't want to keep you. But if you have questions, if you want to work through problems, if you have questions from your exam or anything else, you can do that. Also, so as we approach the end of the semester, if you're trying to maximize your grade, my recommendation is to maximize your exam scores. That's where you're going to get the most bang for your bucks. Once your exam score, because again, you should still be able to access all assignments, including exams. You should still have unlimited attempts. I think it's a 10% late penalty, so the highest you can earn is maybe a 90% on old assignments, which still isn't bad. There may be an extra credit opportunity, but it'll be automatic. So if I can do it, I will. But if it skews the grades too much, then I more than likely won't. And it shows up in the form of your overall MyMathLab score. If I can add it, scale it to where it's 10%. I'll scale it to where it's 10% of your overall. Let me see. I think you're okay. I'll do it. Again, provide. Like this. Mute. All right. So so today we'll do a study session. We'll go through as many questions as we can together. On Wednesday, that'll be an attendance quiz. You gotta pass it. So you need to get a 70% to be marked as present with no hiccups. You get below 70, then you're at my mercy. It just depends on my mood. You can anticipate maybe anywhere from five to 10 questions, somewhere in that range. I haven't decided how many questions yet. Unlimited attempts, and it's only going to be available during class on Wednesday, right? So that's how we're going to get our credit for Wednesday. Once you do that, and again, you can work together. You don't have to do that stuff individually. I usually do pools, so everybody usually has different assignments, but you guys can work together. You don't have to do any of this stuff alone. Okay, so that's Wednesday. So next week, so after this week, we only have 2 sets of new material left, two new sections remaining. Normally on Wednesdays, we do a study session, but next Wednesday, so we're going to do it a little bit different. So Monday, we'll do I think the next section is 3.1 exponential functions. And then instead of doing a homework session on Wednesday the 20th, we're going to go ahead and do the final section of new material, which should be, I think it's section 6.4, system of linear equations in 2 variables. So we'll go ahead and do the remaining 2 sections on Monday and Wednesday of next week. So then what that affords us is that week of November 25th, that's the week of Thanksgiving. We're going to go ahead and start reviewing for the final on that Monday, November 25th. we are going to meet that Monday, right? So we'll go ahead and use that day to review exam one. This way, when we do it this way, we'll get 3 days for review. So that Monday, the November 25th, we'll review exam one. Wednesday, November 27th, we're not going to meet. I think the school closes at noon that day for the Thanksgiving holiday. So that week of November 25th, we're only going to meet once that week. It's going to be awesome. Essentially, like the fall break is so interesting. We get that Monday and Tuesday off. So that's one thing. And then, approaching Thanksgiving, we only meet once that day. So that's practically a whole week off as well. We have the Thanksgiving holiday, and then we come back. The last day of class is that Wednesday, December 4th. So that Monday, December 2nd, we'll focus on exam two. So probably exam two study guide, just trying to review and dust off the cobwebs and, refresh our memories. And then on that Wednesday, December 4th, that'll be the last day of class. We'll focus on exam three along with those two additional sections. So that's what we'll do on that day. Let me see. And then so the reading period is the 5th through the 6th. And so for right now, there's a high probability that I will facilitate your final exam. Usually, like if we were in person, usually for College Algebra 1, it's a departmental final exam. It's made by it's a final exam that's basically all College Algebra 1 students have to take. Usually that's what we do, but because we're remote, I think for the past few semesters, I've just been facilitating it. That's a simple thing. Because I don't think they've gotten to that level of doing a departmental final remotely. They haven't gotten to that level yet. So I say that to say you can anticipate me facilitating your final. So what that means is that you can expect the final to have a similar structure to exams 1, 2, and 3. It's just going to be cumulative. So basically a little bit from everything from the beginning to the end. It should take you about 2 hours, because I think we normally have an hour, so the final you get twice as long. It should take you about that amount of time. Actually, so with our final, you can anticipate it to become available that Sunday morning, December 8th at 11 a.m. And it'll be due, you'll have access to it for 5 days. It'll be due on that Friday, December 13th. That'll be the hard deadline, not only for the final, but for all assignments. So again, as we approach the final, now is the perfect time to get caught up on any outstanding assignments. The idea or the goal is when you take your final exam, you want that to be the last thing. You don't want to have a whole bunch of lingering things past the final. Okay. So again, hard deadline for all assignments that Friday, December 13th at 11:59 p.m. And that's a hard deadline because shortly thereafter, we have to calculate final grades and submit final grades and things of that nature. If you need help, you just have to speak up. You just have to ask and collaborate between me, your classmates, a tutor, Pearson, internet. One of those sources, something you click, or on your own. Many students get it on their own, but not everybody gets it on their own. Okay, so that's a rundown of the tentative remaining schedule. We'll probably review that each time we meet for a while. As usual, if you have questions, feel free to unmute yourself to get my attention and we can talk about it, or put it in the chat or the Q&A. I am monitoring those, and I think that's the meat and potatoes of what we need to talk about. So again, today we'll go through as many questions together as we can. I would encourage you to maybe watch the recordings from my 9 a.m. And if you want, you're welcome to stay on the call. I meet another group after you all. So I have a 2 p.m. and I just let it be one long stream for my 3 p.m. And so if you want to stay on the call, you're welcome to, just if you want to see more questions, right? But if you feel okay, then once class is out, you're free to go. But again, I would encourage you to not only view yours, because it's like 77.
Professor, I'm so aggravated right now. Like, I'm just so upset. I just had to tell you. Hope my day gets better.
Go ahead. You got to expound on that. I don't know what that means. I don't know if your mic went out. You still there? All right. Well, we're here. Yeah, the thing with this, like, honestly, I'm assuming that maybe you're behind or something of that nature. I don't want to be like there's still plenty of time, but essentially there's still plenty of time, right? I'm doing air quotes. I know you can't see me. Um, I've Anything can still happen. I've had students be at the bottom of the bottom at this, with this amount of time left. Like, I think when we looked at the calendar, we got about a month, right? 4 weeks, right? I've had students that waited till the last like 3 weeks and then they just went in hard and they got everything in. And again, it's not really as bad as it seems. It's like, again, as we approach the final, if you're trying to like go back and submit like late assignments, it's okay. The strategy is, the recommendation is, prioritize the exams first, right? If you don't get anything else submitted, if at least you get your exams to like a B or an A, then I don't want to be like you're sitting pretty, but you should be fine. Like, you'll be within range to get whatever score you want. Like, and then, so you would prioritize the exams first, and then if you just have the energy and the time, you want to prioritize the homework last. That's because the homework is going to be a lot of work for minimum points. The homework is really there to just kind of as practice to get you ready for the exams, and we just try to make sure that you get some credit for it. But the bulk of your score comes from the exam. So it's a total of only 4 exams, right? Unlimited attempts. If you can just do an exam per week, right? You'll make it to the end. Unlimited attempts. So even if you get a bad score, it's only going to take your highest score. So you have nothing to lose and everything to gain. You just kind of got to make up your mind, make a plan, and take action. Right? Anybody can do well. It's really designed like the way the real structure of this course. We don't expect you to be. At least I personally don't expect you to be mathematicians. Really, the idea is we're just trying to expose you to these concepts. Have a dialogue, and then we got to hold you accountable on some level. With it being remote, it's not proctored. You're not like in a room with just paper and pencil and a calculator, like in a traditional sense. So, I mean, it's okay. Like, it's really okay. Again, the idea is like we're just trying to expose you to these concepts, and then we just gotta hold you accountable on some level, right? So it's just just have to kind of collaborate and ask for help. It's like if you wanted to take this stuff and sit down with a tutor and just go line by line, it will be okay. I promise you. Like it'll be okay. So it's just a matter of having the confidence to like know that you can do it, make a plan, take some action, and I promise you it's going to be okay. Now, if it has to be more rigorous, we'll cross that bridge when we get to it. But for right now, it is what it is. Just like be easy, be gentle with yourself, make a plan, take some action, ask for help. Like you don't have to do this stuff alone, and you got plenty of time. Again, the recommendation is try to maximize those exam scores. By the time the finals release, we're going to have a total of 4 exams, and right now we still have 4 weeks left. So if you can just do maximize 1 exam per week, that's a decent formula to position yourself for success in this course. Like again, I'm telling you, like it's totally possible. You just got to make up your mind. Okay. So enough of the encouraging on the soapbox, and I know you guys can do it. Again, you wouldn't be here if you couldn't do it. It's just, again, you just have to convince yourself that you can do it and then take action. Let me see. So we'll start with question 16. That's fine. Let's try to get through some of these guys. We got a solid 30 minutes. Yeah, and we don't have a lot of time together. Like it just goes so fast by the time I finish announcements and kind of getting everything booted up. Our time is really precious. I do the best I can to try to be here promptly and start promptly. This is question 12. What's it? 16, right? How come we're on 12? Let's go to 16. Okay. So this question comes from section 2.1. Okay, that's fine. Question 35. It says, for this equation, determine whether the graph of the given quadratic function opens up or down, and then find the vertex. Okay, so this has several parts. Since it has several parts, I'm just going to go ahead and do this for myself. Does the parabola open up or down? I won't count this as like poll the audience, as an official poll the audience, but I am curious to see what you all think for this one. I do want to get you all's input as much as possible. So I'll just do a one question poll quiz. Yeah, let's just do one question at a time. Not the 25 one, let's do this one. Watch. Okay, so just take like a few seconds, maybe like 30 seconds. And I'll try to zoom in here. As a matter of fact, let me put this here. It usually works a little bit better like this. Zoom out a little bit. Oh no, come on. Guess we can go like that. That has the pertinent information. Okay, yeah, you can go ahead and submit it. Let me see. So yeah, it's either A opens up or B opens down. Oh, come on, right? So let me see. So it's a parabola. The highest degree is power of 2. So whether it opens up or down is from the leading coefficient. Notice the leading coefficient is positive, right? So it should open upward. Okay, I'm going to close that. Okay, so it opens upward. It should be the first one. Let me see. Yeah, let's go with that. I might have to change my zoom. Let me go here and zoom out some. Come on, you can do it. Oh, that's decent actually. Oh no. Final check. Let's go. Okay. So then the vertex. So then the vertex of the parabola. I'm going to take some notes here a little bit. I know it's probably a little bit small. So the vertex formula, let me get rid of this. Settings off. So the x coordinate of the vertex, let me see. I'm going to say x, come on, equals h. The x coordinate of the vertex, which is h, that's going to be negative b over 2a, right? That's the vertex formula. That's the x coordinate of the vertex. So then in this case, type an order pair. Let me see. Our negative b, so double negative is positive. That's going to be a 4 divided by 2, which is ultimately just 2. Okay. So the x coordinate of the vertex is 2. So then when x is 2, the corresponding y, that's going to be a 4 minus 8 is negative 4 minus 12 is negative 16. So it looks like it's 2 comma negative 16. Again, we use the vertex formula. The x coordinate of the vertex, which is our h, is going to be negative b over 2a. Ultimately, we got that result was a 2. We took the 2, plugged it in, and we got negative 16, and that's good. Okay. So then the axis of symmetry is going to be the x coordinate of the vertex. So that's going to be x equals 2. Okay. And then the x-intercepts. Let me think. Can we factor this guy? Let me take some notes here. So I want to see if we can factor it, that'll reveal our intercepts quickly. So because the second sign is a negative, I know my signs, that tells me that my signs have to be opposite. One is positive and one is negative, right? And then because the first sign is negative, that tells me the larger number is negative. Two numbers that multiply to give us negative 12 and add to give us negative 4. Is it negative 6 and 2? Yeah, I think so. So 2 and negative 6. Okay, let me see. So 2 times negative 6 is negative 12. 2 plus negative 6 is negative 4. So then if we use a zero factor property, set each one to 0 and solve, we get negative 2 and 6 for our x-intercepts. Now we could check, right? We could either do synthetic division. We should get a remainder of 0 in either case. We can just plug them in. I'm just going to go with it for now for the sake of time. Okay. Y-intercept. So for the y-intercept, we said x to 0, and you can quickly look at that and get a result of negative 12. Okay. The graph. What was our vertex? Our vertex was 2, negative 16. So 2, negative 16 is here. I think we got 0, negative 12. I got to drag that one. Okay, I think we got it. We said 2, negative 16. That looks good. Okay, I'm going to hit save. So basically, I plotted the vertex and the x-intercept. We can, if we were doing this manually, we can use the axis of symmetry. So when we went left by 2, we were at -12. That means when we go right by 2, we're also at -12. Whenever we get a point on the left, we can use the axis of symmetry to get a point on the right and vice versa. Okay. All right, I'm gonna minimize the poll for now. And I'll zoom in a little bit just to make it a little bit bigger. And I'm pretty sure my pencil is charged. So I'm gonna take this guy out. Pretty good. We got credit. Okay. Let's do another random generate. Let's go to question 26. Question 26. Now it looks like they went back. They changed, somehow it changed the structure. 26. Okay. All right, so this one looks interesting. Let's see. If a baseball is projected upward from ground level with an initial velocity of 32 feet per second, then its height is a function of time given by this guy. What is the maximum height reached by the ball? So the height is given by this position function. Notice that this position function is a quadratic that has a negative leading coefficient. So that means we can anticipate a U-shaped curve that opens downward, right? So then if we want to find a maximum height, well, that's going to occur at the vertex of this parabola, okay? So we can find the x-coordinate of the vertex using the vertex formula, which is our -b over 2a. So I'm going to take some notes here. X equals, again, we said -b over 2a, okay? So then -b is ultimately going to be a double negative. So I'm going to kind of skip the negative part. It looks like it's a 1 because 2a, 2 times 16 is also, what, 32? So then the maximum height occurs after, what, 1 second? Okay, so when x is 1. Okay. So then when x is 1, the corresponding height looks like it's 16 feet. Because if you plug in a 1 for t, it looks like it's 16 feet. So I'm just going to go with 16. Because it's going to be -16 plus 32. Should be 16. Okay. Again, if anything isn't clear, feel free to either unmute yourself or type in the chat or the Q&A. I am monitoring those so we can make sure to get your inquiry resolved. It's 2:22. Today is 11:11 and the time is 2:22. Interesting. A lot of synchronicities today. I don't know if you will call it trying to activate keto or ketosis or anything. That's low-key what I'm doing, but not really. Just trying to remove sugar out of my system. So I'm trying like soda water, like unsweetened soda water. And it's like basically I'm like I know my taste buds will get acclimated if I make that my options where I am, and like if I just keep not giving myself sugar, I will get used to it. Like that's been my experience. So soda water is kind of like yeah, but I feel like it's the lesser of two evils between sugary drinks. You know what I mean? Okay, find a quadratic function of this form. So basically we want to fit this data to this model, right? So we got lucky. This one isn't too terribly bad. We just plug in that x and y and solve for a. If we plug in that x value, -2 quantity squared becomes a +4. So we have 4a equals -16. So then a must equal a -4. So then it should just be -4x squared, right? And you could check, if you plug in -2 for x, you're going to get +4. +4 times -4 is indeed -16. Okay, that was a fun one. Generate. All right, we can do 7. That's fine. I don't know why it's giving these numbers so low, but that's fine. All right, this question comes from 2.1, question 13. Find a quadratic function that has this vertex whose graph passes through this point, and write the function in standard form. I'm going to take my notes here, right? So the standard form of a quadratic is going to take on the form of a times x minus h quantity squared plus k. That's the standard form of a quadratic, okay? Now they gave us the vertex. Let's try to plug in what we have. I know because I'm taking it here, it's a little bit weird. We don't know a, so I'm just going to leave it. Now our x is going to be the 2, right? The vertex are h and k. This additional point is our x and our y. So then we can say something like -2 minus 0, so I'm going to leave it as -2 squared. Our k is 0, and that should equal 8. Okay, so because the vertex was at the origin, that eliminated the h and the k. So I just plugged in my x and my y. -2 squared is 4. 8 divided by 4 is 2, so it looks like a equals 2. Okay, so if a is 2, so we have our a, we have our h, we have our k. Now we can just plug everything in. We said what, 2? Okay, let me do it here. So then it should be 2 times x squared, because h is 0. Our k is 0. I guess that's it. Let's get rid of all of this. Now let's just check and make sure that this works. Okay, so notice that when x is 0, the corresponding y is 0. When x is -2, -2 squared is a +4 times 2 is a +8. So both of these ordered pairs work in this quadratic. They both work, so we're going to go with it. Okay, hopefully I'm not moving too fast, and hopefully we're all aboard and we're not all bored. Let's go to question 67. Let's go to question 67. One of my elders would say, only boring people get bored. And you can tell that the people, they don't register, and I was like, damn, he's right, because I don't never be bored. Even even when I was a student, if the professor or a teacher was bored, I know when I was in high school and the younger grades, just to keep myself awake and listening, at least, even if my eyes weren't focused, I would draw and doodle. I would just do stuff, doodles and things, just to keep myself awake and entertained. I used to do origami and all this kind of stuff, artwork. I used to use my mathematics to create unique origami structures and modular origami. It's a lot of fun. It's tedious, but that's the intent. It's like you get into this. It's like a moving meditation kind of experience, and then by the end of it, you have this beautiful whatever it is you're working on. Anyway, all right. So let's see. Okay, so list of potential rational zeros. So this is the it says do not attempt to find the zero. So this is asking about the rational zero test. Remember, with the rational zero test, the list that we generate is not going to be the actual zeros, but we're saying that if our polynomial has rational zeros, it's going to be somewhere in that list, right? So we're going to do our P over Q, where P comes from the factors of our constant term, and Q comes from the factors of our leading coefficient. So in this example, we got kind of lucky because our constant term only has one factor, which is itself. And our leading coefficient only has two factors, which are 1 and itself, right? So we would at most have what, two outcomes? It would be 1 or 1 over 11, and plus or minus of those, so 4. Right? So it should be B. I probably could have asked this one, but for the sake of time, check yours. Okay. Yeah, I just kind of want to keep it moving today. I'm trying to get through as many of these. All right. Let's generate. Why are you staying low? Anyway, this was question. Okay, it's not necessarily staying. I forgot, just that quick. Okay, 15 is fine. Right here. Graph this function by writing it in standard form and then using the transformations. Find the vertex, axis, okay, yada, yada, yada. So they wanted it in standard form. Now, with my earlier group, I did complete in the square. We got our A. We could use the vertex formula to define H and K. So instead of doing completing the square here, I'm going to use the vertex formula. I'm just curious to see if I can get it to work, right? So I'm going to take some notes here. The x coordinate of our vertex, which is going to be our h, that's going to be negative b over 2a. Okay. So let's see. It's going to be a negative 12 over negative 3 times 2. So it will be a double negative, so it's going to be a positive. So I'm going to say 12 over 6, which is a 2. So the x-coordinate of a vertex looks like it's 2, so that's our h. And then we need to plug it in to solve for k. Okay, so let me put it here. It looks like a is -3. I'm going to see if this works. If it doesn't, we'll come back and fix it. We got the x-coordinate was 2, so it should be x minus 2 squared. And then when x is 2, the corresponding y, let me see, 2 squared is 4, times -3 is -12. 2 times 12 is 24, minus 12 is 12, minus 11 is 1. So it looks like the corresponding k is a positive 1. Okay. So we got a vertex of 2, 1. And so for a, I just pulled it from the original. You know, I think in that form, it should be the same a. So that's where I pulled that from. I think that should be okay. That's why I'm testing this out. And so all we did, we used the vertex formula and we just plugged, once we found the h and the k, we plugged it into this. We already had we plugged in h and k into our standard form. And we're going to go with this. Let's see what happens. Check. Cool. Okay, so that worked. So we have at least 2 ways to get quadratics in standard form. Either we could have done completing the square. Let me zoom out some. We could have done completing the square. And that's I know that tends to give students a harder time. I try to showcase it just so that you can see a demo of it. But there are, like what we just did now was an alternative. Instead of doing completing the square, we just used the vertex formula and then filled in the parts, right? Okay, so our vertex we had was 2, 1. Graph the function. Are they doing transformations? The vertex we got was over 2 and up 1, and it should open downward. So I'm thinking the only one that it looks like the blue in part B. All right, it looks like B is the only one because again our parabola should open downward because we have a negative leading coefficient. So that would eliminate C and D altogether. They don't have anything opening downward. I think that the black is like just the original parabola, and then through transformations, you know, we got to our standard form. But the A and B both open downward, but we said the vertex was over 2 and up 1. And so B is the only one that moved in the right direction. So we're going to go with that one. Okay. The vertex we got was 2, 1. So the ordered pair 2, 1. Yeah, like right at about 10 minutes remaining. The axis of symmetry, again, is going to be the x-coordinate of the vertex. So that's going to be x equals 2. Okay. Ouch. X-intercepts. Okay. I feel like it's kind of easiest to do that from once we have the standard form. We can set the standard form to 0. We get some fractions. So we subtract 1, divide by -3. So we get, I should write it out. We get x minus 2's quantity squared equals a positive 1/3 square root. So now we got a square root of 1/3 or plus or minus square root of a third. So the x-intercepts we get are 2 plus or minus the square root of a third, or root 3 over 3. Okay, so we said 2 plus or minus square root. We can do square root of 3 over 3 if we rationalize. Simple. Okay, I think this is good. Because it's really the square root of a third, you know, which would be 1 over the square root of 3. You have to rationalize. So you get root 3 over 3. Let's go with this and see what happens. Okay. Let me just kind of recap. I know I'm not writing it out. I know I'm just doing this audibly. So how I found that, I use this standard form. This guy right here. I set this guy equal to 0, and then I solve for x. Once you get it in standard form, I feel like that's one of the easiest ways to solve for the intercepts. If you set it to 0, you subtract 1 first, so you have a -1 on the other side. Then we would divide by -3, so double negative becomes positive. So then we'll have x minus 2 quantity squared equals a third. And then we take the square root. You got to remember, when we take the square root, you got to do plus or minus, and then add 2. And that's how we got that result. Okay. I know that's a mouthful. If you need to see it written out, just let me know and I'll write it out. The y-intercept. So then the y-intercept oftentimes is much easier. You just let x be 0, and you can quickly look and see that the answer should be -11. -11. Okay. All right. I don't know if I told you all, like, this summer was the first time I've tried like growing stuff. And literally, like, this is like maybe my 4th or 5th iteration and literally of like trying to grow different things. And literally, like, the other day, I finally got some sprouts. So the first, and basically what it was, because like we get all this food and we just be throwing away the scraps. I'm like, yo, I think we can grow from all this stuff. Like if it have seeds or certain things. So like I had my celery stalk, and instead of throwing away the root, the base, the stem or whatever, I I just cut off the excess what I wasn't using, and then I just put it in a cup of water. And about a few days later, it started sprouting. I put it in a cup of water in the windowsill, and the place, it doesn't even get direct light; it just gets like some light throughout the day. And it finally sprouted. I was like, "Oh crap!" It finally sprouted. And so next to it, I had like the base of a green collard greens, and I was about to throw it away because that one was not sprouting. And then today, when I went to check it to throw it away, it sprouted too. I was like, "Hey!" So then it's like, if you like, to me, that's mathematics in motion, or poetry in motion, because if you get it down to a science, that's free food. We be throwing away. We First of all, we pay for everything that's free. We think that we can't generate energy or electricity, but we can. We pay for everything that's free. It's just that we don't take the time. We've been tricked and duped and into being lazy and dependent on officials, where like if we just take the time to figure it out, then we don't really need them. We can do for ourselves on a lot of this stuff. So like with the food, if I just threw that away, I'm throwing away food. I'm throwing away like unlimited food. So now I've been able to sprout it inside of a basement or whatever, and it's essentially unlimited free food. It just takes a little bit of effort to take the scraps and see, can you get it to grow. And again, all I did was put it in water, and that was it. And put it in the sun, and it started sprouting. So if I work it right, if I get it down to a science, put some space to the side for that kind of stuff, now you can have unlimited free food. Just a little bit of that's why I study mathematics, because of stuff like that. It took me a while to figure out why mathematics. Then I realized that math is, because it always felt redundant to learn math to just go back and teach it. It just dawned on me that math is a tool that you use to be successful in life. It teaches you how to compartmentalize, organize the information, think critically, see the opening, see what needs to be filled in, and then make a plan and take action. So it's analysis. It's critical thinking. What are you trying to do? What do you have? What are you missing? Can you substitute for the missing item? How can you adjust? And then put it together. So if you do this, then maybe it'll work. And then you try it. It's either a yes or a no. If it's a no, then make an adjustment, try again. If it's a yes, then see if you can fine tune it. That's mathematics/science in action. Critical thinking in science, they'll call it the hypothesis thing. I can't even think of the name of it. Any other time I would know it. But you make a hypothesis, the scientific method. That's what I was trying to think of. Anywho, we still got a solid 5 minutes. Let me see. Okay, we're on question 22. It feels like all these questions are coming from section 2.1, and I was trying to get it to jump around. A quadratic function is given below. Determine whether it has a max or a min. Okay, this is fine. So it is a quadratic because the highest degree is a power over 2. The leading coefficient is negative, right? Leading coefficient is negative, so that means the quadratic should open downward. If it opens downward, then that means we're going to have a maximum value, right? So we're going to have a maximum value. Okay, that's based on the leading coefficient. So then we can find that maximum value by using the vertex formula. Remember, the vertex formula is going to give us the x-coordinate of the vertex. Then we use that x-coordinate to go back and find the y-coordinate. And that y-coordinate will be the max value, okay? Okay, so let's take some notes here. Yeah, I was like, I don't know. It just dawned on me that we're paying for everything that's free, and I'm like, I'm sick of this. I'm not going to pay anymore. I mean, I'll pay if I have to, but I'm going to figure out as much stuff as I can and teach as many people as I can until I get taken out, either by natural causes or foul play. Because I'm just like, this is ridiculous. Like, I refuse to just keep paying for stuff just for the sake of going along with the narrative when I know this stuff is free and we have a right to it. Because I know that this is our land, because if we really were African, try to deport us there. You can't deport somebody to where they're not from. Maybe at some point down the line our ancestors were, but if we truly were from there, they could just send us there. They can't send us there because that's not our home. So that's enough for me, to be like, look, we have a right here. We got to be ready to defend it to the nail. Because you know how they are. They like to come at you like that. So anyhow, negative b over 2a, right? So negative b over 2a, okay, equals. So double negative again, you should be able to see it. Our b is 20, so I'll go ahead and put that. Our 2a, so 2 times 2 is a 4. So it looks like the x coordinate is 5. Okay. So that's the x coordinate of the vertex. Then we can use that to go back and find the corresponding y. Synthetic division probably would be a little bit easier, but I'm short on space. So 25 times 2 is going to be a negative 50 plus 100 is what a positive 50. So ultimately it's going to be a positive 7. It's going to put 7. Now what we could have done is taken that 5. I got it. I think we have 5. And we could have done synthetic division, and then the remainder would have been f at 5, right? But anyway, so it should be 7. Okay, so I think we're good there. What's the range? So the parabola opens downward. We have a max value of 7. So then if the max value is 7, so then the very bottom is negative infinity up to 7. Okay. Check. Max value, we need to put a square bracket. Come on. There we go. I'm going to do this blind. Okay. Yeah, I think we're just missing a grouping symbol. Okay. Let me glance at one more. Hopefully, it just depends on how long I think it's going to take. Let's go to question 47. If I feel like we can do it in about 2 minutes, then I'll go for it. 47. Let's look at it. So this does come from section 2.2. Describe the end behavior, right? So with something like this, the recommendation is to expand it out first, or at least just those first terms, because it's tempting to just do the negative 6x squared, where in reality, it's actually negative 6x cubed, right? You kind of have to distribute that first term. So if the leading term is negative 6x cubed, we have a negative leading coefficient, so that means our graph is going to go down to the right. And then the highest power is power 3, which is an odd number. So that means the other side does the opposite. So that means our graph should go down to the right and up to the left. So fall to the right, nope. Rises to the left and falls to the right, so it should be C. Okay. So if any of that was foreign or made you anxious or jittery, you just got to go back and get some more practice there. Sketch the graph using the graphing tool. I'm just going to, now it's in factored form. Maybe we can use that. We know it's this tool. It looks like when x is, I guess I'm going to just plot 4 points. So when x is 0, it looks like it does pass through the origin. I'm going to click 4 times. 1, 2, 3, 4. And I know the origin is one of my points. So I'm just going to drag this to the right. I guess I could just type it. Yeah, let me just type it. Trying to get you all out of here. Come on. Come on. Submit. Okay, so we got 1 point there. Let's do when x is 1. When x is 1, 1 plus 1 is a 2. 6 times, is negative 6 times 2 is negative 12. So 1 and negative 12. Hopefully that'll be okay. Can I setting off? Oh, okay, whatever. Come on. You're not working either? Okay. We got a 1. This one should be negative 12. Okay. Let's see. Did we lose our image? We lost it somehow. Oh, that sucks. It's not letting us do it. Okay, we're out of time. Yeah, I don't know. It's just throwing a tantrum. Oh, like this. I see the time I'm about to. I'm probably just gonna let this one go. Hit refresh real quick. And I know it probably could be another one. I'm gonna just try real quick. We were working. It was like 47. Okay, cool. That's how we want it. So I think we had the origin. Let me see. Right here. 1, 2, 3, 4. I just clicked on 4. Here. Yeah, that's fine. 1, 2, 3, 4. I just clicked on 4 random. And then I'm just going to type them in manually. Submit. Okay, we got 1 and negative 12. Edit coordinates. Hopefully, I think it's the same. Come on. I see the time. I'm trying to get you guys out of here. 1. Here we got negative 12. Submit. Okay, that's behaving properly. Let's see. Let's do. Come on. There it is. Let's do negative 3 when x is negative 3. Let me see. 9 times 6. I think that goes off the charts. Yeah. Let's do negative 1. Looks like it's 0. Okay. So we'll do negative 1, 0. That's another point. So edit. Come on. Negative 1, 0. Okay. And we need one more. Okay. Let's try negative 2. Hopefully it doesn't go off the chart at negative 2. Negative 2. Let me see. That's a negative 1. That's a 4. Negative 24. So positive 24. So negative 2, that goes off the chart. Looks like we may have to do a negative 1.5. Let's see, that's a negative 1/2. Hey, Google, what's a negative 1/2 times negative 1/2 times, darn it, I didn't do it right. Hey, Google, cancel. Let me try one more time. I see the time I'm getting you guys out here. This is it for the whole shebang. We got a negative, so that's a negative 1/2. Okay. Hey Google, what's negative 1.5 times negative 1.5 times negative 6 times negative 1/2?
Minus 1.5 times minus 1.5 times minus 6 times minus 1 divided by 2 is 6.75.
6.75. Okay. 6.7. Oh, not that one. 6.75. Edit. So we did 6.75. This was a negative 1.5. I think it was a positive 6.75. Cross our fingers. 6.75. I'm just trying to rush to get you guys out of here. It has the right shape. We got lucky. So that last point was a little bit challenging. We had to do some decimals. We had to do a fraction, but that's okay. Let me hit save. It looks right. It has the right shape. I'm going to check. Cross our fingers. God is good. All right. A little bit of effort. We got lucky. It didn't restart us. All right, gentlemen. Let me see. if there's anything pertinent. So again, we kind of went through the tentative schedule at the start of class. If there aren't any burning questions, we're actually just going to go ahead and end the session here. And again, on Wednesday, we're going to do an attendance quiz. Again, it's only available during class, so you want to be here a little bit early. Anywhere from 5 to 10 questions on Wednesday. Then once you finish that, as long as you pass, then you're good to go. You can only access it during class on Wednesday. All right, gentlemen, again, if there aren't any burning questions, we're going to go ahead and end the session here from one beautiful mind to another. Enjoy the rest of your evening, and we'll meet back on Wednesday, same time, same place for the next installment. All right, guys, take care. Peace.
Thank you.
Uh-huh. All right, I'm going to go ahead and make a copy of this available. Let me see. I'm going to share. What's this one? Share. Box. Let's go. I got 10 minutes. That took me a little bit longer than I would have liked. That's okay. Fall. That's not right. Fall. Traditional. One. Notes. Updated daily. Okay. So folder upload. Let's go ahead and prep for the next group. So I need a copy of this. Copy. New. Paste. This is item 58. 3P. Ooh. Here. I need to import this assignment. Get to a good amount. Excuse me. Let's see, right here. Manage. Ooh. Import. Next. Just need not the blueprint. 2 p.m. is fine. This assignment way down here. This one. Import. Okay. Back up real quick. Manage. Do. That's fine. Yeah, that's fine. Yeah. So I got 5 minutes. Let's generate. Ooh. Okay. Fine. Oof. screen. Broadcast. Siri, set a timer for 3 minutes.
3 minutes.
Oof. Testing, testing. Yeah, it's still working. Okay. I am going to lay down for 2 minutes. Famous last words, right? Oh. Shift kills. We didn't tell you guys about that. Siri, stop. All right. Oh. Sure. A lot of space, but it's comfortable. Yeah, that's better. All right, T minus 15 seconds and counting. All right. 5, foul, 3. And we're live here at W Display. All right, gentlemen. Okay. Oh. So welcome. Okay. So hopefully, I hope everyone had a great weekend, productive or restful or whatever you needed it to be, exciting, mysterious, adventurous, wondrous, whatever you needed it to be. Hopefully, that's what it was and more. Glad that you all are here. Let me think. Oh, okay. Yeah, let's start off here. So let me see. No, go away, go back. Okay. So let me see. I kind of want to go through a tentative schedule for the remainder of the semester, right? So this week is exam 3, right? Over chapter 2. So today, what we're going to do is, do the homework session. We're going to go through as many of the corresponding homework for this exam as we can. From I just made a study guide. You'll find it at the bottom. It's just for practice, so it's just there if you just want to use it. But yeah, so that's available now. So we'll go through as many questions from the study guide together as we can. On Wednesday more than likely we'll do an attendance quiz. Again, it's only accessible during class time. I do intend to be here, so I'll probably be on the call. But again, once you do that quiz and you need to pass it, that's like at least a 70%. Then once you finish that, you can go on Wednesday. It'll be anywhere from like 5 to 10 questions, somewhere in that range. I wanted it to take you about 20 minutes to do it, so that way you can get like at least 2 or maybe 3 attempts within the class. Again, on Wednesday, that assignment is only going to be available during class. You got to pass it to get attendance credit. If you don't pass, then you're at my mercy. And if I'm not in a good mood, I'm not going to get you credit, right? So either just be sure to pass it. And again, you don't have to work on that assignment alone. You can work on it together, in the chat or whatever. I do tend to make it so that each of you guys have different exams, but again, I don't. Me doing that is what makes me comfortable with you guys working together with this stuff, because then I know that everybody has their own thing that they're responsible for. Okay, so that'll be on Wednesday, and then next week. So after this week, we only have two sections of new material remaining. So normally on Wednesdays we do homework, but we're going to change it up next week on Wednesday a little bit. So on Monday, you can anticipate, I think the next section is section 3.1, exponential functions. And then on Wednesday, which is the 20th, instead of doing the corresponding homework for that section, we're going to go ahead and do the last of the new material, which is going to be, it should be section 6.4, system of linear equations and two variables. So we'll do that on Wednesday, the 20th of next week. And then the week after that is going to be that Monday, November 25th. That's going to be the week of Thanksgiving. We will meet on that Monday. That Monday, the 25th, we're going to take that as our first day to review. So and with us kind of pushing up that last new section, that gives us 3 days to review for the final. So that Monday, November 25th is the first day that we're going to review. We're going to focus on exam 1 on that day. So November 25th, we're only doing questions pertaining to exam 1. All right. So I think that's like the first half of chapter 1, something like that. And then that Wednesday, the 27th, that's Thanksgiving. So the school closes at noon on that day. So we're not going to meet on the 27th. We break for holidays. So for Thanksgiving. So, take that time to try to enjoy your time with your loved ones, your friends and family, whoever, if you have anybody that's like that, because everything is changing rapidly. You blink your eyes, next thing you know, 5 years are gone, 10 years are gone by, people dropping like flies. You're like, Jesus, what is going on? So, it's important that you show up to like family events and just, try to make your presence known, because no day is promised, right? Yesterday's history, tomorrow's a mystery, today is a gift. That's why they call it the present, right? So try to enjoy your holidays. Do what you need to do as far as the work is concerned, but try to enjoy your holidays. So then when we come back after the Thanksgiving holiday, that Monday, December 2nd, we're going to work on focus on exam 2, right? And then the last day of class is that Wednesday, December 4th. And we'll focus on exam 3 along with those 2 additional sections past exam 3. Okay, so then the 5th and the 6th is the reading period. And then that second full week of December is going to be the week of finals. you can anticipate your final exam. More than likely, I will facilitate your final. Usually for College Algebra 1, there's a departmental final, but because we're remote, I think that, it's okay that I facilitate it. It's just that's the simplest thing, and that's what we've been doing for the past few semesters. So you can anticipate our final to become available on Sunday, December 8th at 11 a.m. And then I want to say it's due on Friday, December 13th at 11:59 p.m. That's the hard deadline for all assignments. Okay. So, idealistically, as we approach the final, you want to try to get all of your assignments on Pearson that you have access to, just try to get them in order. So that way, when you take the final, in an ideal world, the final should be the last thing that you submit, right? You don't want a whole bunch of lingering assignments past the final. Also, if you are going back to do like old assignments to boost your overall grade, may I encourage you to prioritize your exams first, because that's where you're going to get the most bang for your buck, right? That's the least amount of work for the most points. And then once you've taken the time to get your exams where you'd like them to be, and then I would encourage you to prioritize your homework last. All right. So the homework is a lot of work for minimal points. The intent of the homework is really just there to give you practice in preparation for the exams, and then the showdown are the exams. All right. I think at this stage we have at least like 4 full weeks remaining, essentially, give or take a day or two. So if you were going back, if you could just get like, if you give yourself a rhythm of making sure like 1 exam per week is up to date, that'll be a good position to be in, as you complete the final. Right. Again, we have a total of about 4 exams. There's 3 exams including the final. And then if you can make sure at least 1 exam per week is in order starting right now, then you can position yourself for whatever grade you want in this course. Also, I think there are course evaluations available. You should have gotten an email about it, so it's a good idea to do those as well. I kept forgetting to remind my other groups, so you're like the first group I was able to remind. So just be sure to check that out. That's available. I think that's the meat and potatoes. Okay, so yeah, I can't think of anything else. So okay. So what we'll do today, again, we're going to take some time to go through as many of the homeworks for the study guide together as we can. We'll start with question 23. And this question comes from section 2.1, question 49. Let me see. It says a quadratic function is given below. Determine whether the given quadratic function has a max or min value. Find this value and then find the range. Okay. So max or min value, notice that this is a quadratic. The highest degree is the power of 2. So that means we should be working with a U-shaped curve. Notice that the leading coefficient is negative. All right. So if we have a negative leading coefficient, this U-shaped curve should open downward. Right. So if the U is opening downward, that means we're going to have a maximum value. All right. We should have a maximum value because we have that negative leading coefficient. Okay. So then to find that maximum value, we can use the vertex formula. All right. So let me see the vertex formula. The x coordinate of our vertex, which is our h, the formula is negative b over 2a. Okay. I'm just taking my notes here. So let me see. That would be a negative 20 over 2 times negative 2. So it's a double negative is positive. It's a double negative is positive. 2 times 2 is 4. 20 divided by 4 is ultimately 5. So it looks like the x coordinate of the vertex is 5. But they didn't want that just yet. They wanted the maximum value. So we find that by taking this value and plugging it in. Now we could do synthetic division, and then the remainder would be the function evaluated at 5. I'm just trying to work in this space. You know what? I'm going to do a makeshift. Let me see how I can do this. Put my comma here. I'm going to do a makeshift synthetic division, all right? So like, for instance, if we did 5 in our chair, I'm going to separate it like this. That's fine. I don't think we need any placeholders, so we could say -2, 20, and -41, right? So I'm basically just trying to emulate synthetic division. So if we were doing synthetic division, oh shoot, I need another space. Darn. I'm gonna try. Let me see. Can I just? What if I do this? Let me see. Can I do this? All right, I'm gonna try. Okay, so this will be my -2. I know this is weird. The -2 comes down on the diagonal. We multiply. So 5 times -2 is a -10. And then if you add that, that'll be a +10. And then 50, 5 times 10 is 50. I know it's out of alignment just because of the structure. But anyway, the 50 is under the 41, and I think this is going to be our remainder. And it looks like a remainder of 9. Is that right? The 2, 10. Yeah, I think so. Let me think about it. Give me a moment. What do we get? 9? So we're saying that if we plug in 5, we should get a 9. Okay, I'm going to get rid of all these notes. Again, our x we got was 5. We got a result of 9. So before I do this, I'm going to just plug in 5 and see what happens. Let me see. So 5 squared is what? 25 times a -2 is a -50. Plus 100 is a +50. Minus 41 is indeed 9, right? So again, I took that x value, I passed it through synthetic division. The remainder is going to, again, the remainder theorem is going to be the same as, the remainder is the same as f of 5, right? Which in either case, we got 9. Okay. So I know that those notes are a little bit jumbled. All right, so we got a max value of 9. So then what's the range? The very bottom is -infinity up to 9. And I think we include the 9, we actually reach it. So we're going to use a square bracket. Okay, all right, get rid of this. All right. Let's go to another one. Generate. Let's go to question 70. Let's go to question 70. Right there. Okay, find all rational zeros. I feel like we should take notes. Yeah, we need to take notes. All right. So I'm gonna put you there. I'm gonna move you. Sure. Perfect. All right. Let's see. Let me get a screenshot of this guy. I get a copy of the pertinent information. Okay. Then fill in it. Okay, so like that. Right there. We're gonna, come on. It's decent. Okay. So now here we're asked to find the zeros, okay? Let's start off with the rational zero test. We're gonna start off with the rational zero test, okay? So again, the way the rational zero test goes, we're gonna do our P over Q. We're gonna generate a list of possible rational zeros. Again, this list it's not the list of actual zeros. We're saying that if this polynomial has rational zeros, it's gonna be somewhere in this list that we generate, okay? So we're gonna have P over Q, okay? Our P comes from the factors of our constant term. So let me see, that's plus or minus 1 and 14, 2 and 7. I think that's all the factors. So that came from the factors of the constant term. We got lucky because our leading coefficient is a 1. So the factors there are only one. So then this just happens to be our list. Okay, we got lucky here. Okay, so now the next challenge is finding that first zero. So I'm a fan of efficiency since we can use this stuff. I'm just going to look at the graph. Let me see. I need another one like this. Matter of fact, let's go like this, full screen. Let's go here. Now we want to pop this guy out, like so, like that. We left off here. Let's have back chill. Okay. Come on. Okay, I'm gonna try my typing. Yeah, see, where is it? Right here. Okay. So I'm gonna go to my equation editor. We got x hat 3. What is addition? Plus is okay. I can do it here. Plus 4x cubed. Oh shoot! I see the mistake I made already. X hat 3. Nope. X is here. Hat 3 plus 4x squared is I. Yep. Minus. Nope, that's not the right one. Draw. 19x. X is here. And 14. Okay. So then I'm just going to look at the graph and see if I can spot. Okay, we got a couple of places. It looks like 1 is a good candidate, right? So let's see if 1 is a 0. We're going to do synthetic division. I'm going to get rid of this for now. So I'll do synthetic division starting with 1. So we'll let 1 be a potential 0. We don't need any placeholders because every power is accounted for. It's going 3, 2, 1, 0. So we don't need any placeholders. So we just take the coefficients of 1, 4, negative 19, and 14. Okay. The 1 comes down. Diagonal, we multiply, we add, we multiply, we add. Listen, it's looking good. Oh, yeah. Boom. All right. We started with the degree 3. So at this point, we're now at a degree 2. So it's called a depressed equation. It drops by 1 degree. Okay. So we found a 0. I think 2 was a 0 as well, just piggybacking off the graph. So I'm going to use my depressed equation, or actually, we can factor at this point. I think factoring might be a little bit easier. So if 1 is our 0, then the factor is going to take on the form. It's going to be x minus 1, right? And then we want to try to factor that remaining part into some form like this. I'm going to set it to 0, x and x. Because my second sign is negative, that tells me my 2 signs are opposite. So 1 should be positive and 1 should be negative. Because the first sign is positive, that tells me the larger number is positive. 2 numbers that multiply to give me negative 14 and add to 5, or what? 7 and negative 2? 7 and negative 2, right? 7 times negative 2 is negative 14. 7 plus negative 2 is a positive 5. So then this is going to be the completely factored form of the original. We could check by expanding all the way out. So when we have 2 or more things that multiply to give us 0, then by the 0 factor property, we set each factor to 0 and solve. Ultimately, we get our zeros to be negative 7, 1, and 2. Okay. All right, that was a fun little adventure. Let's hop back. Let me see. Just grab you. Yes, that's fine. So we got negative 7, 1, and 2. I didn't check it just for the sake of time. We want this one. We'll suppress you here. Let's go. Let's go. Thank you. Negative 7, 1, and 2. That's what we got. Awesome sauce. All right. The chat looks good. I feel like there should be questions, but you know, it's okay. Oh, wait, we got something. Okay. Let me check the Q&A. Okay, so the question is the final exam. Let's see. How can I? Okay, I'll just make a note. Yeah, so the question was the final will be online. Yeah, more than likely, it'll be like the others. I'll proctor it. I just want to mark it as answer. Answer live. Okay, that was good. Yeah, so what we've been doing for the past few semesters, I've been the facilitator for hours. I make it. You can anticipate it to become available, I think we said Sunday morning, December 8th at 11:11. And the hard deadline for all assignments is that Friday, December 13th at 11:59 p.m. Okay. So you can access it for about 5 days. And then, that hard deadline, everything locks out because we have to calculate final grades. Okay, that's a good question. Let's go to question 46. 46. Ooh, it was good to be standing up. I made myself my temporary podium. The 4 hours between my morning group and you all ended up doing some yard work, like clearing out leaves. So I almost didn't finish. It got kind of wild. Like I was getting exhausted and frustrated, and then this leaf blower, it's like a cart style. I don't know. It needs some attention. Like I need a welder. I need a weld. I need to strengthen it. The bar is weak, so I can't put pressure on it. Otherwise, it collapses. So I was getting a little frustrated. I set it down, and then I had a hand blower, and I was blowing off like some edge or whatever. I look over my shoulder, and the thing just takes off down the hill. I was like, "Fuck!" I felt like if he was watching it, it would be funny, and it looked kind of funny, but it was dangerous. Like there's nobody out there, so I was just like, "Well, I'm not gonna chase after it." So I let it go till it stopped. It kind of flipped over upside down, and it kept like sputtering. It started to cut off. I was like, "Well, it should just cut off." Then it started smoking. I was like, okay. I ran over there quick because I was like, damn, I don't want it to explode. I had a gas canister attached to it. I was like, I do not want this to explode. And I knew I needed to stand it up rapidly. Like the longer it took me to stand that thing up, the greater the chance it was going to explode. So I hesitated for a split second, and I was like, no, I got to do this now. I can't wait. So I went over there and just stood it up and then put my back to it and just kind of got away from it. In case if it did explode, I can kind of shield a little bit, you know what I mean? Just try to shield, soft spots or whatever. And I was like, that's enough of that. So, I didn't even bother trying to start it because I know that, like, it was basically the gas was leaking out. So if I just let it, like, dry out, put it upright in its proper position, let it dry out, and just next time I go to use it, just start it in a safe space. It should be okay. So it should be okay. I mean, gas does periodically get out, but again, I'm giving it time to like return to homeostasis or whatever. So I finished the rest of the yard with like my other blower. So then after all of that, so that's why I'm a little bit exhausted or whatever. But it's okay. We only have like 20 minutes left. So okay, so given this function, answer the following question. Describe the end behavior and sketch the graph. Okay. Let me zoom in some. So end behavior, right? So we use the leading term test. The leading term in this case is x to the power of 4. So then from there, we use the leading coefficient. The leading coefficient, come here, right here. I know you, come on, right there. Oh, come on. Put that there for you, go. Oh, making me waste food. Come on, guys. Okay. Let me see. So the leading coefficient is positive. It's a positive 1, right? So that means that the graph should go up to the right. And then the degree of the polynomial is 4, which is an even number. So that means the other side does the exact same. So our graph should go up to the right and up to the left. It should rise to the right and to the left based on that leading term. So it can't be C or D. I think it's A. Graph rises to the left and rises to the right. Okay. So I think based on that, we can eliminate D, right? Because that's opening in the wrong direction. Maybe we can look at some intercepts. let's see. Let's start off with the y-intercept. So if we let x be 0, it looks like it should pass through the origin. So it could be A or B, but it can't be C because C does not pass through the origin. Okay. Let's do when x is 2. 16, 8. Let's see, that's a 16. Is it going off the chart? When x is 2? Let me see. When x is 2, 4, 16, 49, 56. So 56, 66, 72. That's going off the chart. When x is 0, the origin at 2. Oh, okay, there it is. And that's 100. Yeah. So B is correct, right? Because A, if we look at the graph of A, when x is 2, is not going off the chart. So A wasn't correct. C wasn't passing through the origin, so that's not correct. And D is opening the wrong way, so that's not correct. So then the only one that's behaving correctly is B. Process of elimination. And all I did my leading term test, and then I just kind of chose a few points to test out, just to match it up. Close. Okay. Let's generate. Let's go to question 31. Okay. Determine if the following function is a polynomial. So we have one polynomial divided by another. And if we distribute that monomial, we don't get our powers are wrong, right? I think for it to be a polynomial, the powers have to be non-negative integer exponents. And if we say x squared divided by x cubed, we're going to have a negative exponent there. So this is not a polynomial. Generate. Okay, we can do 70. I think we did 70 in my other group. We did 70. Okay, we'll do 71. Okay. Find the zeros of the polynomial. Okay. No placeholders. I think we need to take notes again. So let me do this. I'll get a screenshot. Okay. Drop a copy right here. Come on. It's close. Cool. All right there. Okay. So another demo on the rational zero test. Okay. So let's generate our list of possible rational zeros. We're going to do our P over our Q. Okay. The factors of our constant term come from 2, so it's plus or minus 1 and plus or minus 2. And the factors of our leading coefficient are 6, coming from 6. So that's going to be 1 and 6, and then 2 and 3. Okay. Okay. So we need to do all combinations of the red over the blues without any repeats. All right. So if it's a repeat, then we only need one copy of the repeats. So then it's going to be plus or minus 1, plus or minus 2, and then plus or minus a half. But 2 over 2 is 1, which we already have. And then plus or minus a third, and then plus or minus 2/3, plus or minus a sixth, and then 2 over 6 is a third, which we already have, right? So again, if this polynomial has any rational zeros or somewhere on this list, hopefully we can find a zero between 1 and 2. I think I'm gonna just go ahead and do my synthetic division instead of looking at the graph. So first I'm gonna try 1. Just now we ask ourselves, do we need any placeholders? Every power is accounted for. It goes 3, 2, 1, 0. So every power is accounted for. So we take our coefficients, 13, 1, and -2. Okay. So we're gonna do our synthetic division. Okay. That's a 6. Diagonal, we multiply, we add, that's a 19. Multiply 20, 20, 18. So it's not a 0. All right, okay. Let's try -1. So right now we're doing guessing and check. This is why I like to look at the graph instead of doing guessing and check. See, can we quickly find the 0 by looking at the graph? But I'm just going to keep going with this. I'm going to try -1. So it's a 6, 13, 1, and -2. -6, 7, -7, -6, 6. That's a 4. Again, that's not a 0. So that's not 1. Let's just go ahead and try 2. Because I'm hoping it's a whole number, so it'll be a little bit easier to work with. 2, 6, 13, 1, and -2. 6 times 2 is 12. Oh man, look, it's getting out of hand. 23, so 25, 50, 51, 102, 100. Nope, not a 0. Let me try -2 real quick. 6, 13, 1, and -2. So because of this is why I like to look at the graph, but now I feel committed. I feel vested. I just want to finish. 6 times 2 is -12, 1, -2, -1, +2. God is good. We found that 0. All right, that's what we were looking for. Okay, so we found 1 0. We started with a degree 3. So that means at this point, we're now at a degree 2. Okay, so if -2 is our 0, then our factor takes on the form x plus 2. Okay, and then we want to see, can we factor that remaining part into something of this form? We're going to set it to 0, x and x. Because my second sign is negative, that tells me my two signs are opposite. So one has to be positive, one has to be negative. Because my first sign is positive, the larger is positive. We're looking for, wait a minute. The leading coefficient is not a 1, so we gotta back up. We're looking for two numbers that multiply to give us -6 and add to give us 1. I think it would be 3 and -2. But what I'm going to do, I'm going to use the box method here. Like this. So I'm going to put my 6x squared up here, my constant in the bottom right. And that 1x, I'm going to rewrite using the two numbers that we found. We got a +3 and a -2. So I'm going to say this is going to be a +3x. This is going to be a -2x. Okay. So again, that 1x we rewrote using those two numbers we found. Okay. Now from here, I'm going to use my box method. The 2 on top, the greatest common factor, looks like a 3x. The 2 on bottom looks like it's -1. The 2 on the left looks like it's a 2x. The 2 on the right looks like it's a +1. Okay. So then with that, we get the following. So our claim is that it factors into 3x minus 1 and 2x plus 1. Okay. So then now from here, because it's now we have it in a completely factored form, we set each factor to 0 and solve. We get zeros of -2, -1/2, and a +1/3. Now, we could do synthetic division with these fractions in the original just to confirm that they work, but you know, I think that's good enough, right? So far. So -2, -1/2, and 1/3. Here's positioning curve. -2, -1/2, and 1/3. -2, comma, -1/2, 1/3. Type integers or fractions. Okay, awesome sauce. So that one was a little bit extra with the factoring, right? Let's just do a quick recap. So again, you know, normally with these, like, so first we started with the rational zero test. We had a lot of fractions. We had minimal like whole numbers. So that's why I just went on and guessed and checked the whole numbers. It was going to be at most 4, and it just happened to be, I think, -2 worked, right? The last one. You know, we could have looked at the graph, and then we may have noticed the -2, and we may have started at the -2, right? And then once we got it down to a quadratic, we factored it. We could have also used either completing the square or the quadratic form, and we would have gotten these results as well. Okay. All right. Let me see the time. We got just under 10 minutes. So we got time for at least one more. It just depends. Okay, we can do 68 right here. Okay. List the potential rational zeros. Do not attempt to find the zeros. Okay. So our P over Q, P comes from the factors of our constant term, which is a 1. Q comes from the factors of our leading coefficient, which is 5. So in this case, it looks like it should be A. Okay. Generate. Let's go to question 55. Ho, 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 right here. Right there, 55. All right. Use synthetic division to find the quotient and remainder when this polynomial is divided by this other polynomial. Let me see. Oh, they're giving us fractions. They're trying to be funny. That's okay. Let's zoom in. Let's zoom in again. All right, we're gonna take this. So let's get a copy of this guy. Like every time we get close to class being out, I get like antsy. I just like that's all I can think about. But I don't want to shortchange you all on time. So I try to like just keep working the example. I try to stop watching, you know, but you just gotta time flies when you're having fun. So, you know, just try to have fun as best you can. I know it can be kind of drab and boring. Okay, synthetic division, right? Okay. Where's my pen? I know it's nearby. There it is. I like my little modular podium. Basically, it's just different size boxes from different gear that I've gotten lately. So when I want to like be standing up, I make it kind of tall, and then when I'm writing, I need it to drop down a little bit. I adjust it. It's kind of fun. Okay, you know, you get older, you just start to appreciate the simple things. Sorry, just the little things. You got to take your celebrations and your victories where you can. Man, the first time, man, my back went out for the first time. I was like, shit, this is like, you know. And at first I thought it was like the bone or something. Come to find out, I guess it's just a muscle back there that's not being worked. So I got like these little massage balls. And so yeah, they're really hard, like about the size of a little bit smaller than tennis balls. So, you know, if that ever happens, I just grab that and lay down on top of it and just massage it until it kind of comes back in. And you just have to wait it out. It is, you know, it's a nightmare if that like happens in public. I don't think it's ever happened in public. You know, where some wood. I mean, knock on some wood. You know, but anywho, okay. Let me focus. Let me see the time. So 5 minutes. Okay, synthetic division to find a quotient and remainder when this polynomial. Do we need any placeholders? 3, no placeholders. So now, if this is our factor, then the 0 is going to be the positive 1 over 5. Oh, you done? What? You were like almost full when we started. There's no way you can be that. Let me see. Let's see. Let's see. So 1/5. There we go. Goes in the chair. I think we don't need any placeholders, so it should go 5, 13, -3, and 1. Okay, so we're just gonna do what we normally do. First one comes down. Diagonal we multiply, vertically we add. So 14, oh, it's starting to get funky. Diagonal we multiply. So if that's 3/1, so it's gonna be what, a -15/5. So then it looks like it's a -1/5. Oh man. Okay. -1/1. 5 to 5 is 25. So then if we add 24/25 is our remainder. Okay, we started with a degree 3, so at this point we're now at a degree 2. Okay, with that remainder. Okay, let me see the time. We might have time for one more. This one. Integers or fractions. I don't know if it's not tantrums, we're not gonna have time. Okay, quotient. Let's go here. Come on. We might have to have a little more. Okay, so we got 5x squared plus 14x minus 1/5. Okay. And the remainder we got was 24/25. 24/25. Okay. Wow. Okay. Let's try to do one more. Generate 73. Let's look at 73. This will be the last one, 73. If it doesn't take too long. Find only the rational zeros, so they want us to find the zeros. Okay. Let me go like this. And it says only the rational zeros. Okay, let me get a copy of this. There. Okay. Drop that right here. I'm gonna try my augmented version. Okay, that's decent. Okay. Got like 2 minutes. Like that. All right. So let's do our P over Q. Q. Factors are 6. 1 is 6. 2 and 3. Okay. And the leading coefficient is a 1, so we got lucky there. I think I'm just going to look at the graph to find that first zero, just in the interest of time. Y equals and clear. Clear is this one? Okay. X hat 4. Nope. Right here. X hat 4 plus 2x hat 3, 2x hat 3. Okay. Minus, so withdraw 5 tilde hat 2. Okay. Or we can say I instead. So minus 4x minus 4 tilde plus 6. Okay. I'm just going to look at the graph. Okay, it looks like -1. Looks like it's only 1, 0. That shouldn't be right. Wait a minute. Go to y equals x to the 4, 2x cubed minus 2x cubed minus 5x squared. Okay. It should go in the same direction, graph. Maybe it goes further to the right. But ooh, and it doesn't look like negative. Why does it feel like something is off? Let me check again. X to the power of 4 plus 2x cubed minus 5x squared minus 4x plus 6. And it doesn't look like it's negative. Maybe there aren't any. Or maybe it's not 6. Yeah, there might not. I'm gonna say that there aren't any. Only the rational zeros, so there might not be any rational zeros. I think that's what's going on here. I don't think any of these are gonna work. Let me see. I'm gonna. Oh, maybe we're not doing something right. There's not an option for that. Let me see if I do -1. That's a -2. That's going to be a -1. -6. -2. That's not a 0. I don't think -2 works either. Okay, if there's no answers, I want to view an example. I'm going to see what happens with theirs. Continue, yada, yada, yada. So they got a 0 there. Why does our graph look so weird? Let me check something here. I don't know why it wasn't showing up in the graph. I see the time. I'm trying to get you guys out of here. Let me just try synthetic division real quick. I think one of the ones might work. I'm just gonna try it real quick. Come on. Okay, so let's try -1. We don't need any placeholders. 1, 2, -5, -4, 6. 1, -1, 1, -1, -6, 6, 2, -2, and that's a 4. All right, that's not a 0. Let's try 1. 1, 2, -5, -4, and 6. 1, 1, 3, 3, -2. Okay, this looks promising. I don't know why it didn't show up in our graph. -2, -6, -6, and we got our 0. Okay. Okay, so we got 1 as a 0. We started with the power 4, so now it's power 3. I see the time. X squared x. Okay. Maybe it bounced. Because sometimes the zeros occur multiple times, so I'm going to try 1 again. And I'm going to use 1, 3, -2, -6. Okay. 1, 1, 4, 4, 2. Nope. 2, -4. So that didn't work. Can we factor that? Well, it looks like they can be factored. Okay, hang on. So that's an x minus 1 times, we got an x cubed, 3x squared, 2x minus 6. I think we can factor that. I'm trying to get you guys out of here. The first two, we can factor out an x squared. It'll leave us with x plus 3. If we factor out a -2, it looks like it's an x plus 3. Okay. So then we'll get x minus 1, x plus 3, x squared minus 2. So it looks like it's a 1 and -3. So it looks like -3 is one of our zeros. I want to verify that -3 is a 0. Matter of fact, just because we're short on time, I'm just going to submit 1 and -3. And then the other 0 is not rational. But I'm going to submit 1 and -3. I think that's it. I'm trying to get you out of here. Come on. We said -3, 1. Okay. All right, so we kind of rushed through that one a little bit. I know that was a little bit intense. So because I started to think there were none, but then there was no option for none. So when I viewed an example, they got one of the ones to be a 0, so we tried it, we got it. I think what's happening is, I don't know, we have some irrational zeros at play, so it's kind of making it a little bit weird. But anywho, okay, are there any burning questions before we go our separate ways? Going once, going twice. Exam 3 is out now. And so again, on Wednesday, we're just going to do an attendance quiz. My intent is to be here. And then it's just, again, you need to pass that quiz to get attendance credit today. Again, that assignment is only going to be available during class on Wednesday. Okay. So with that, if there aren't any other burning questions, we're going to go ahead and end the session here from one beautiful mind to another. Have a great rest of your evening, and we'll meet back on Wednesday, same time, same place with the next installment. Take care, guys. Peace. I'll go ahead and make a copy of these notes available. Go ahead and end this.